Let me show you how to do some problems that Duggan and I call jambalaya. Jambalaya, because it's a spicy mixture of the force of lifting and dragging and power and work. Okay. In fact, all of these things, we can actually make little triangles out of these things, right? Okay, so for example, if we're lifting, force is M times G, right? We make a little triangle out of that, right? And so force is, cover the F up, it's M times G. And write this down, okay? Make this is part of your cheat sheet, write these formulas down, okay? Put these things in here too, right? Okay? This is your ultimate cheat sheet. You need this one and you need one for energy, basically. Okay, and G is, of course, 9.8. But this, if we want to find the force is M times G. If we want to find M is F over G. And we know what G is, so we don't need to find that, right? And then there's also the force of friction, right? We can make a crazy triangle out of that, right? Force and mu and M and G, right? And then, we can do the same thing, right? This is our coefficient of friction. If we want that, it's force divided by mg. If we want the mass, it's force divided by mu g. And if we want the force, of course, it's mu times m times g. And this is, of course, 9.8 as well. Okay. And then we've got our power is work over time, right? Which, as a triangle, looks like this. Work, power, time, like that. Right? So power is work divided by time. Time is work divided by power, and work is power times time, right? And we can do the same thing with work. Work is force times distance. So these are all of these things for jambalaya are just they're just triangle problems, right? Work is force times distance. Distance is work divided by force, and force is work over distance. Okay, so let's draw the line of demarcation here. Okay. So let's hit a arrow here. Let's get an example problem. Okay, a 1.2 horsepower winch can lift a 2,350 kilogram Land Rover 14.5 meters in the tree, right? What time does it take? That's what we're trying to find out. So I think I need to turn the horsepower into watts, okay? So 1 horsepower, 1.2 horsepower is 1.2 times 745. That's just a conversion factor. Right, and that is, if I do that, 1.2 times 745.7, 894.84. So that equals 894.84 watts. Okay, so that's my power. Okay, and then 2,350 kilograms, that's my mass. Okay, we are definitely lifting it up in the tree, right? So we're going to ignore this formula for now, right? The coefficient of friction doesn't apply if we're lifting. Okay, 14.5 meters, that must be our distance. Okay, and now we're just looking for formulas that we can apply. And I think because we're lifting, I think the only thing we can do is actually find the force, right? So let's find the force. The force is M times G, so it's 2,350 times 9.8. So let's see, 2,350 times 9.8, that's 23,030 newtons, right? So I'm going to put that down for my force. Okay, so let's see, what do we know? We've already used this guy here, right? So we're not going to use that again. I think we can do work. We have force and we have distance, so we can find work. So basically, just look over here. If you can apply a formula, do apply it, and then write down the answer, right? Okay, so work is force times distance. We have force, we have distance, so work is force times distance. By the way, all these things are, pretty much all of them are 3-step problems, right? So that is, let's see, our force is 23,030 newtons, and the distance is 14.5 Okay, so let's see, times 14.5. I already had the number on my calculator. My goodness, that's such a lot of work. That equals, people don't say my goodness enough, you know. Try to say my goodness sometime today. My goodness. Okay, so that is our work. 333,935 joules, right? So that's my work. And let's see, what do we want? We want a time, right? Time is what we're trying to find. It's the last thing. Okay, this one must be the one that'll get us time, right? Power is work divided by time. So let's find it. Time, then, if we cover up T, is work divided by power. So time is work divided by power is 333,935 joules divided by, let's see, the power is, there it is, 894.84. Okay, so divided by 894.84, and I get 373.18 seconds, which is what I got before. Yay! Let me do another example that has friction in it. Okay. Okay, so let's see. 45.1 kilogram, that's my mass. Okay, so Gummy Bear drags a 45.1 kilogram box that has a coefficient of friction between it and the floor of 0.34, a distance of 16 meters in 11.7 seconds. What is her power output? So we're looking for this, right? This is my mass, that's kilograms. Let's see, coefficient of friction. That's my mu. That's what they look like. They don't have units. 16 meters must be my distance. 11.7 seconds is my time. Okay, and we're just looking for a formula we can use. Let's see. We are dragging, right? We're definitely not lifting, so I think we can find the force. Force is mu times m times g. We have mu, m, and g is 9.8, right? So let's do that first. Force is mu times m times g. So 0.34 times 45.1 times 9.8. 0.34 times 45.1 times 9.8. 150.2732. So that's not my force. You know, you probably only need to write down like 4 digits. I'm just writing them all down like that. You don't want to round too much, but there it is. Okay, let's see. We've got force and distance. I bet the next thing to do is work, because work is force times distance. So work is force times distance. That's my force, and my distance is 16 meters. Right, that's newtons, just newtons. Okay, times 16. 24, so I got 2,404.3712 joules. That's this guy, right? 2,404.3712. Okay, let's see. I guess power is the last thing, right? We must be able to calculate it, and it's just work divided by time, right? So power is work divided by time. My work is the 2,404.3712 divided by, what's our time? 11.7 seconds. Okay, so divided by 11.7 is 205.5. What's the unit of power? Okay, so that's how you solve the type of problem called JAMBALAYA!